guess we're live.
Yeah, perfect.
All right.
Let's get going. Welcome to Build. It's amazing how it's another year that goes past so quickly. My name is Mark Fussell.
And my name is Vaslav Turacek.
And we're here to talk to you about what's coming with Service Fabric and all of the grand work we've been doing to make Service Fabric a great distributed systems platform and focusing great on microservices and the road ahead for this. So we've seen tremendous growth of Service Fabric over the last year. We now have thousands of customers running on our platform. And we've seen, it's interesting how the conversation has changed from when 3 years ago when we launched Service Fabric at Build, it's what is a microservice? So now it's like, oh, so how do you build these things? Tell me how you use it all. So we kind of got over that hump of trying to understand what a microservice is. And it's kind of pretty accepted now that that's the way you're going to build your services. The great thing about Service Fabric is a platform that we designed from the ground up as a microservices platform that you can build these sort of scalable distributed systems where you can build everything that can suppose as small pieces of code. And when you look at our platform, it goes everything from the developer side of things. We have a set of rich programming frameworks. We provide out of these boxes reliable services, reliable actors for you to build your own microservices on that design pattern. But of course, you can just run an executable. You can run containers inside here. And of course, it then all the way goes through to the ops side as well, where you do all your operational side, how you do your rollouts, your life cycle management, your health, how you do all of your scale out of your underlying cluster. For us, one of the most exciting things actually is the release that's just gone out, our 6.2 runtime release. Now at this point, we actually have all the pieces in play, where we now have the GA platform so that you can build Windows, .NET full framework applications, .NET full framework applications on Windows. You can build them on Java, build Java applications on Linux, and you can build .NET Core applications across both Windows and Linux. And of course, this time last year, we announced Windows container support. We launched Linux container support at Ignite, and then you've already been able to run executables. So right now, with the current release, you can say that all the pieces in play that you can now mix and match and build an application consisting of some containers, some of the reliable services and the reliable active runtimes we provided, or bring your own executable and put these all together into the one platform. So we're pretty excited about where we are, and we continue to add innovation each release that we push out on a regular cadence basis. You see that we push out releases to our environment running inside Azure and standalone at least every 2 or 3 months. So it's not only our customers, it's also our own services. We showed this list of services last year that all build upon Service Fabric as its core platform, and the growth of these services has been tremendous. Cosmos DB, SQL DB, these services exist because Service Fabric is the key underlying platform that allows them to scale and achieve all of those great capabilities that you expect from a distributed systems platform. But we've added more. In the last year, all these services, everything from Azure Container Service, the Event Grid, other databases, Postgres, MySQL, all of these now build on Service Fabric as the underlying platform. And each day, we see tens of thousands of new cores launched that run Service Fabric, because that's the platform that we see running these services. In the month of January alone, we saw 500,000 cores launched on Service Fabric across the company because of the scale of how we run these services. So we're very used to scale. We're very used to dealing with how you run large-scale services, and pretty much Service Fabric is becoming the de facto platform that we build most of our new services with inside Azure. Another exciting thing that we did was that we open source Service Fabric. Hopefully a lot of you heard about this. Hopefully it was an exciting piece of news for you. So a couple of months ago, we open source Service Fabric. We made it generally available. You can see all of that source code, and we're going to be developing that now into a open source development model over the next few months.
And we're still working on that too. We're still getting our development process out into the open, but we're committed to it though. It's coming.
So this points to the fact that Service Fabric is a key foundational platform that we use to build our own services. We bet our own company on it, and so we have to make sure it runs pretty well. And the great part is we give it away for you for free. So when you look at the landscape of Service Fabric, there are 2 products that we have today. There is the on-premise product that we call Service Fabric Standalone. You can take this, you install it on a set of machines, you network them together, run one PowerShell command. In under a minute, you've got a network cluster of machines running. And then, of course, we have Service Fabric that runs inside Azure, where you get a managed cluster there for you, and we take care of upgrading the underlying runtime and helping you there basically not worry about hardware management, but effectively just manage a cluster. One thing that we've seen a lot is a lot of people come up to us and say, well, we'd love it that you helped us a lot easier with how we manage our on-premise clusters. And how is it that you can make sure that instead of me digging around and finding all the packages that I need to install locally, can you provide something that helps me configure my local cluster more easily? So one thing that you'll see that will launch in the next few weeks is the ability to describe a JSON manifest you have. Think of it just like an ARM template. And it just describes a list of machines given their IP addresses and other configuration you want in there, like deploy the certificate across those machines. And you can upload this into Azure. We'll look at your JSON manifest, and we'll look at the type of deployment you wanted, a Linux deployment, Windows deployment, and we'll download all the relevant packages that you need with the best configuration for the environment that you want onto your local machine and configure it. So you can stand up a local cluster here by simply uploading a definition, and then we'll pull down all the packages and build a cluster for you, all again with just a single PowerShell command that hooks up into Azure. So this will make it much, much easier now for you to configure that local cluster. Now at this point you can walk away and say, I'm done, I've taken that great freebie and I'm going to use it all myself. But you can actually go a stage further at this point, because we also know that people who run standalone clusters also usually have Azure clusters. So what this means is, because you're going to register it with us in Azure, we can actually have a single portal experience now where you can see all of your standalone clusters, the ones that you're running on premise, as well as all your Azure clusters, all managed through a single portal experience inside Azure. And then from there, you can do upgrades, you can do queries, you can do certificate management across both these environments, which we think is going to be super cool in order to help you manage your environments a lot easier than you do today. So this is coming. This is how we're actually going to deliver you Linux on-premise. So if you've been wondering, you gave us Windows on-premise for a while, how am I going to get Linux on-premise, Linux standalone? We're going to deliver it to you in this mechanism, and you'll see this coming in the next few weeks. But of course, you know, we still see the fact that there's a word cluster in here. And a cluster still amounts for over the majority of our support calls. You know, when customers phone up, they say, how is it I scale up my cluster? How is it, what's this thing called a VM node type? How is it that I manage the certificates in my cluster? And we see that there's still, you know, a lot of decision making that you have to make in terms of how you manage your cluster and do all the operational side of all of this. And there's also things around in the application space as well. How is it that you set up a gateway that routes to all your services efficiently and things? So we look at all these challenges and we think to ourselves, well, how is it we can deliver a better Service Fabric experience than we do today, but we take away even more pain from you? So we're pretty excited to announce that we're going to launch a new service for Service Fabric that we are calling Azure Service Fabric Mesh. And what this is a fully managed experience for Service Fabric running in Azure, where you as the application developer simply build an application and give it to us to run. So now we, Microsoft, stand up large clusters of machines. We'll stand up that thousands of core machines. You just have all the fun of building applications and deploying them and running there. So if you were to think that in the standalone world, you have to think about hardware. How do I manage my hardware? How do I manage my cluster? How do I manage my apps? And in the Azure dedicated cluster world today, you don't have to worry about your hardware, but you have to manage about the cluster itself and the applications. Well, with Service Fabric Mesh, you just build applications, deploy them, and run, and scale on your demand. So here's how we think about it. You still have all the capabilities that you think of building Service Fabric applications from a microservices perspective. But now you have a serverless infrastructure approach. Now you don't see any VMs, you don't see any networks. You know, all you do is you build applications. Everything runs inside containers. Everything runs inside, all applications run inside their own isolated network. It's a multi-tenant environment where you can take your applications, run them inside Service Fabric Mesh. You'll build only on the resources you use. We take care of many capabilities around here in terms of how you route the messages across things, how we deal with certificate management, and you'll see as we go through the rest of this presentation that because we've introduced this new offering, which is a serverless offering, effectively where you only run the applications that you want at scale, that we've introduced all sorts of capabilities into Service Fabric itself that actually takes advantage in the rest of the platform itself in terms of the clusters that you already run today. So you get the benefit across the full spectrum of all the types of Service Fabric, whether it's standalone as well as running in Service Fabric Mesh inside Azure. So we're super excited by this. and we're going to show you some demo of this right now, because there's nothing like getting to a demo early. I'm on 7.
You are number 7. Go.
Okay, so what do you expect? You do AZ mesh, and what you see here the ability to do application deployment. You can see the ability to deploy a service. Think of this now as an application, a Service Fabric application, as a first-class resource type inside Azure. Service is a first-class resource type inside Azure. So what that means is I can actually describe an application, describe a set of resources, and I can simply upload those into Azure and deploy an application consisting of a set of services, just like you've always experienced inside Service Fabric today. So if I do AZ mesh app list, you'll see that I've actually today already have deployed two applications running here. I've got a Hello World application, and I have another one that I'll show you in a demo a bit later. So how do I deploy one of these applications? Well, I'll just take a little script here. I can do this AZ mesh deployment, and I create upload a new JSON template and through the AZ mesh deployment command, and this will go off and talk to our resource provider inside Service Fabric Mesh and start deploying a new application based upon this ARM template. Well, while that's deploying, let me go off and show you what that looks like. So, as you fully expect, what is it when you deploy something into ARM? You expect to see an ARM resource type. So here we are. This is my first application I'm deploying here, Hello World. And you'll see that just like you expect to see with everything else in ARM, I have a set of resources here, and I have a Service Fabric application type. And of course, an application consists of a set of services. Well, what's inside a service? Inside a service, you have a service name. You have an OS type of what it's running. And if you're very familiar, you'll see that this itself has a set of code packages. This actual service that gets deployed here, this Hello World service, has a single replica count that will get deployed. So there I have my application deployed with my single service with a single replica count. And if I look inside the code package, you'll see that this deploys a single image inside here, which is a Hello World Windows Server Core image for that application I'm deploying. So everything runs inside containers. This thing here has a particular name for that code package that gets deployed. And you'll see that I can open up an endpoint here on port 80 with a Hello World listener for this particular image. I can then set resources inside here. So this is how you can set the amount of resources that you will run. I just want to run this particular container with 1 CPU and 1 gig of memory, and that's all you'll actually pay for. At any time, you can change these and redeploy all of this. And then finally, you'll see at the bottom here that there's a network reference. Well, what does that mean? If I go to the top here and open up and look at these resources here again, you'll see now that I've defined a Service Fabric network here. What does a network do? Well, all these services that run inside the application run inside their own isolated network. But I've also said to this network, open up a port through the Azure Load Balancer. And so open up port 80 for the Hello World application, for the Hello World service, for this endpoint listener through the Azure Load Balancer, so I can then access particular container image. And now I'll have deployed an application consisting of a single service with a single container image with a port that's opened up through the Azure Load Balancer. So let me go over to, so meanwhile I've been talking here, you see this application is being deployed. If I go and do my AZ Mesh app list, you'll see that I've got 2 Hello Worlds. Now I can do AZ Mesh network list, and you'll see that I will have deployed alongside these services here, and these applications I have a set of networks also deployed. Well, this particular application I just deployed here inside mfossil app 10 resource group, this is this application just here, and you'll see it opens up this public endpoint. Well, let me grab this public endpoint here, go off into your favorite browser, type this in, and ta-da!
Hey.
That's your first Hello World application running in Service Fabric Mesh. So an awful lot has happened here, but think how simple it is now. Literally, you've just written an ARM JSON template file, described an application, describes some services. They're full ARM resources now. You can combine this with all the other ARM resources. So I can deploy this. I can go into this, and I'll show you demos later how you can just change this, redeploy it, scale out the number of instances of your container, change the definition of your app, and do many other things. So this is your Hello World application running inside Service Fabric Mesh. Let me show you one more thing before I disappear here. You can look at here inside the list of resources inside here. So I can do AZ Mesh service list. And if I do this for that service, you'll see that when I execute this, you see inside here that for this single Hello World application I'm running here, here's this service running inside here. So you have the full query capability of the hierarchy that consists of your application running with your set of services. Pretty cool stuff, yeah? All right, let's...
Yeah, so Service Fabric Mesh, you can see it's really focused on writing and deploying and managing applications over infrastructure. But it's not just Service Fabric Mesh where we're talking about doing applications. It's actually Service Fabric in general. Service Fabric Mesh happens to be one way that you can write Service Fabric applications and run them. But Service Fabric actually is kind of evolving to be an even more application-centric platform that runs anywhere, including in Azure and on the mesh. And so different kinds of applications that you can write.
Yeah, well, I mean, so we see two major scenarios. We see this scenario that's happened frequently now where people take existing code and they effectively modernize it, which means that they take code, they package it inside containers, and they deploy that into environments where they can scale out and take advantage of Service Fabric as a platform effectively to modernize your existing application and then build new services on top of all that. Last year, at this time of the talk, we showed a lot about modernization. You'll see a lot of it happening in different talks here at Build. And we see now that Mesh fits into that even greater now because you don't have to deal with the underlying cluster in any way.
And even though Mesh is serverless, we do want to also enable you to be able to bring your workloads, your existing workloads, run them on Mesh without having to worry about VMs or worry about infrastructure. Of course, we're also talking about cloud-native applications where I write applications that are specifically designed to run on Service Fabric or run in the cloud. And we are trying to kind of make this a little bit more easier and a little more generic for you to do. So polyglot services is something we're really looking into where you can bring in any language, any framework, run that on Service Fabric. Enhance those applications with our built-in state stores like reliable collections, and then to be able to interconnect all those services together through intelligent traffic routing without having to actually do your own service discovery and traffic routing yourself. So what this means for us is that there's a couple of changes we have to make to the way applications are structured and the way they're developed and the way they're run in order to be able to run across all of these environments, everything from your local laptop all the way up to this serverless environment running in Azure. And so what we're doing is we're introducing this new concept of Service Fabric resources. And resources are basically individual decoupled things that you can deploy up to Service Fabric. Now this stands next to the other ways that you're used to writing Service Fabric applications today, whether you're using our application and service manifest to describe your applications, or whether you're just doing Docker Compose, which we will continue to support today. This kind of gives you a full gamut of control and integration up to simplicity and portability, where Docker Compose obviously being the most portable since there's no Service Fabric there anywhere, it's just Docker Compose files. Somewhere in between, though, in the middle is this land where I can write something that will run anywhere on any environment. And the only thing you really have to change is the level of integration that your services have with the underlying runtime. So for those of you who are developing on Service Fabric today with reliable services, for example, you're used to having life cycle events and kind of deeply tied into the runtime to the point where your services can actually hold up the runtime. So if there's a runtime upgrade rolling through and your service says, I need more time, or I'm not responding to a cancellation token or something like that, you can actually hold it up. And in a shared environment, in a multi-tenant environment, obviously that won't fly. And then the other thing, too, is, of course, everything has to run in containers in this multi-tenant environment because it's a shared environment and you need that level of isolation. So if you go down to the bottom of the stack there, and you're doing application and service manifest and reliable services, you still have full control, and that's still fully supported and always will be. And you'll be able to have full control of the platform, be integrated in the runtime, and do all the kind of really interesting work that you can do today with it. But in this middle land, it's really geared toward just focusing on application and not actually managing the infrastructure or being involved in that infrastructure lifetime. So it's really a simplification. So let's talk a little bit about what Service Fabric resources actually are. Now, This is just a way to say that anything you deploy to Service Fabric is considered a resource, and they're all individually deployable. And today, that's mainly just your applications and your services. So of course, you can still do that, but on top of that, there are additional resources you can deploy, like networks and secrets and volumes. All these things are individually deployable and shareable across applications. So you can deploy a network and then deploy multiple applications into that network. You can put up a secret and have multiple services reference that secret. And there are other kinds of resources. This sort of opens up the playing field for us to add new kinds of resources in the future as well, like routing rules. So you can say how I want traffic to be routed, and scale out rules and all kinds of other stuff. And we can add these new resources and update existing resources without having to change a central schema either. So this is kind of a new way of doing things here. Now, when you write these resources, these are simply just YAML or JSON documents that represent each one of these, and they can be deployed to anywhere where Service Fabric runs. So this is an important thing to remember. This isn't just a concept in the new mesh service. This actually works anywhere that Service Fabric runs. It's just deployable to your typical Service Fabric management endpoint like you always do. When you're in Azure and you're deploying to mesh, of course, you're authoring ARM templates, Azure Resource Manager templates, and that gets deployed to this Resource Manager endpoint, which is where the mesh runs behind. Now, it doesn't necessarily mean you're going to have to take all your resource files and convert them to ARM templates. Of course, tooling and CLI will assist with that, so you're not necessarily doing this all by hand. But the final result there is going to be basically a JSON ARM template document that you go and deploy up there.
Which is what I just showed.
Which is exactly what Mark just showed, right? So on top of that, in addition to the way that you describe how your applications and resources run, in order to kind of achieve this goal of being polyglot and agnostic to the framework or the language that you want to use, and while we do generally do .NET Core first, we understand that there are other languages and platforms that people want to use as well, and we want them to kind of be treated equally. And so the idea is that when you do describe a service or an application in a resource, you're actually just describing a container like Mark showed, and whatever runs in that container is entirely up to you, so you can put anything in there. And we kind of have a model for that today. We have containers that you can describe in your service manifest. We have guest EXEs. But the idea here is to kind of unify all that so that the guy writing a Node.js app doesn't do anything different from the guy writing a .NET Core app. So they look pretty much the same. And that includes the APIs and all the libraries that you use. So in this world, what we do is instead of having base classes to derive from and frameworks that kind of lock you into the platform, we don't do that anymore. We give you libraries to use. You pull these libraries in, and that gives you the Service Fabric functionality and integration that you're used to, things like reliable collections and client APIs, so you can interact with the cluster or in the mesh environment, interact with your applications to manage them. And so this is a bit of a departure from what you see today. So what I'll do now is I'll switch over to Visual Studio and show you what this actually looks like.
6.
I am number 8. Thank you, sir. All right. And my laptop is shut off. OK, here we go. So here's a very simple application in Visual Studio. This, if you're a Service Fabric developer, this one might even look a little bit familiar to you. This is our quick start application or voting application. What I have on the screen right now, this is your service resource. This is what a service resource looks like to describe a service that's going to run. Now you'll notice a couple things. First, a lot of the Service Fabric concepts that you're used to are still there. There's still an application, there's still a service, and there are still what we call code packages, as Mark showed you earlier. And each code package now just defines an image, a container image to run. And so this is what I meant that by when I say that regardless of what language or platform you're writing on or framework you're writing in, you describe the service the same way. So you don't have to add extra attributes or tags here and there to try to get it to all run. It all looks the same. Every code package that you run describes one container and then what the container needs to run. So environment variables, the resources, endpoints, et cetera. And you can have as many of these as you want, of course, and they'll all run together in a service. Now you'll notice down here I have a network ref, and this is referencing a network description. And this is where you decide, OK, how do I want to set up the network for this application? How do I want ingress traffic to come in? When you go and deploy this out into Azure Service Fabric Mesh, this will automatically configure ingress ports, and so you don't have to mess with the load balancer and all that jazz. You just go and deploy this, and we configure all that and let ingress run right in. Now, the thing to note about these two projects is these are just plain vanilla ASP.NET Core applications. So if you look in the program CS here, for example, if you've done reliable services in the past, what you'll notice is that this entry point to the program is just what you'd normally expect. There is no Service Fabric runtime, service type registration. All of that stuff that you had in your code that immediately tied you into the platform is gone. So you don't have to worry about that stuff anymore, which means I can take the same application and run it anywhere else. I can run it on just my local dev box on its own if I wanted to. I could run it on a different platform. You're no longer tied in to Service Fabric the way you were before. The other thing you'll notice then too is that concept of service types and instances isn't really there anymore. So that's something that we've sort of abstracted out. And if I go back to the service resource, you'll see that what this is defining is just how the service is going to run. It's not really defining a type from which then you'd create instances. If you don't know what I'm talking about, don't worry about it because it's not there anymore anyways. But the whole point is that this has gotten a lot simpler. It's much, much simpler. It's easier to describe and easier to run.
It's all about making life simpler for a developer.
It really is, yeah. So let me just do F5 here. I've just hit F5 and I'm going to run this on a local cluster. And again, this is just Service Fabric. So I'm just running it on my local Service Fabric cluster. And I want to show you something here with these two applications, or with these two services rather. If we look at how the services communicate, you can see that it's just grabbing environment variables to figure out what's the DNS host name of the backend service and what's the port. There's no discovery APIs. There's nothing, again, nothing that ties into Service Fabric. If this ran as is outside of Service Fabric, it should run the exact same way internally. And then the other thing I want to show you is this backend here. I'm going to come back to this in a later demo, so I just want to show you now what this is doing is this is just your typical, I need to put state somewhere, so this is just putting it into a little .NET dictionary here, which obviously means that it's just going to go away as soon as the application shuts down. But we'll come back to that in a little bit, and we'll show you some other ways that we're providing options to store state in a persistent way and some cool new stuff we're doing there. So what I'll do is I'm just going to put a breakpoint in here, and we'll just see if the application works. And we expect that it will. So I'll just say do this. OK. And so it should hit my breakpoint. OK, so that all works the way I expect it to, so big deal, right? Here's the cool thing about this. The breakpoint I just hit is actually running inside of a container. So when I hit F5, that created a container image out of my application, put it into a registry, spun up the container image, and then attached a debugger into the application inside the container image. So my breakpoint, I'm actually running inside the container image. And that all took about, I don't know, what was that, 30 seconds or something? It's pretty fast. The Visual Studio guys have done a really, really fantastic job with this.
An amazing job on the speed of debugging inside those containers.
Yeah, so your deployment and your debugging inside the container is now super, super fast. All right, so let me close this guy down. You want to switch me back to PowerPoint? All right, so actually, tell us more about some of these interesting resources.
Well, one of the things that we hear all the time is about how do I manage certificates, secrets, everything at the application level. So we've done a whole bunch of tremendous work recently where we integrated a Key Vault extension into our cluster deployment. So now you can use a Key Vault extension that reaches up into Azure Key Vault and downloads a set of certificates across the cluster of machines. You can do auto rollover of the certs inside the cluster itself, doing things like as well providing common name support so that you can roll over those certificates for the cluster security. But all the time we hear people say, I need certificate and secrets management at the application at the service level. So that's exactly what we've effectively built. We've built a new service into Service Fabric. It's called a secret store service that allows you to manage certificates and secrets at the service and at the application level. Of course, this actually gives you a couple of other key advantages. The one thing it's going to do is it's now going to provide, as what you need inside Azure, I need managed service identity at the application level and at the service level. So now, because I've got managed service identity, which means I've authenticated against AAD, I can go off and go and get other keys from Key Vault and do things. So that's one of the key aspects that you'll see because we built in the secret store. Equally as well, of course, with that secret store, it means that when you're running an on-premise installation, if you're not even attached to Azure and Key Vault, we can take advantage of storing all your keys there securely and actually making advantage of your certificates as part of that. The certificates, the keys, the secrets, I say, that you manage can both be inline certificates, which are ones that you just provide as part of the secret store, or they can be ones that you pull down from Key Vault. So effectively, what this means now is a service can take its identity with its certificate and register it with AAD, and now it's a fully managed service identity service, and now we can reach out into Key Vault and say, give me a set of secrets that I want, and then it can use that to authenticate with other services inside Azure, such as Cosmos DB and things like this. So what you'll see now is that as a resource type, you can define these secrets. I can define independent of using them in any particular application or any particular service. And now, just as you saw how I referenced that network inside the application, I can now just reference using these secrets if I want to access this particular other Azure resource, like a Cosmos DB. So now, all of a sudden, your certificate management is taken care of for you. The auto rollover of those secrets is done for you. You just have to care about writing code, referencing the secrets, and talking to the back-end service that you want. So it's pretty cool having this as a core part of the platform. And again, as we keep saying, this is built into the platform, so you get this in all versions of Service Fabric, not just Service Fabric Mesh, but also inside your existing clusters that run. The other thing as well that we've spent a lot of time on, I mean, it wouldn't be a Service Fabric talk if we weren't talking about state, because we love state as the as a data-aware container orchestrator. So, we love to make sure that we deal with state. And of course, one of the most common ways you do that is you're just writing file I/O inside your code. You're doing I/O operations right out to your local disk. And so there, what we want you to be able to do is, you see we've deployed all those containers. Well, now you can just be able to hook up volumes to those particular containers and hook up volume drives to those containers of different types. And we've built two types. We've built one that's for Azure file storage. And what that means is that for your service, you can just do file I/O operations, and it will persist that data into Azure file storage for you. Or we've built a local Service Fabric volume driver. And what that means is that when you talk to that volume, we'll write out and do the replication with Service Fabric storage, just as you're familiar with today in terms of our reliable services. But here you just see it as simply as an attached volume. And here, of course, using the local replicated disk, you get advantage of low latency, high throughput, and independence of network storage. And just to kind of show you how this is just a core part of the platform, if you go off right now to this URL, aka.ms/sf file volume driver, we shipped a preview of this. You can download this and use this right now in terms of your current deployments you have, in terms of how you've deployed your applications with the current application manifest model inside there. So it's a great example of how we're bringing these capabilities across all the versions of Service Fabric, because we want you to be able to be productive about building volume disks, whether they're containers running inside your clusters you have today, or whether they're containers running in Service Fabric Mesh. So pretty cool stuff. We're going to be looking at how we push more of these volume drivers out.
Let me show you what that actually looks like, because this is really cool. This is all really cool. So going back to the application we were just looking at, where I said we're just storing data in a little dictionary and that's stupid. So what you can do instead, for example, is take that exact same application, we're looking at the same one in the back end here, and you can use something like, for example, Entity Framework Core. So I have EF Core going here, and I'm now storing data inside of EF Core instead of a little dictionary. And what you do is, in this example, we took EF Core and we're basically just backing it with SQLite. And we're telling SQLite, go ahead and store your data in this database file here in this directory. Now, ordinarily, if you just did this, this would put a file into your container, and as soon as you tear your container down, you lose the file and you lose your data, so you don't want that. So what you do instead is you go back into the service resource, and you're going to say, all right, I want to set up a volume, and I want to mount that volume to that path. So now, whenever something writes files to that path, that's actually write to a mounted volume, and that volume is going to be backed by something that's more persistent than just a local file. So in this case, that volume is the Azure file storage volume, and so here I can set that up, and so now everything I write to that data directory is actually being stored out on Azure files. You can also put in our Service Fabric volume disk, which is backed by Reliable Collection, so that if you're not running in the Azure environment, remember, you can do this anywhere the Service Fabric runs. And you don't want to have to manage an Azure account and an Azure subscription to set up file storage, you can just back it with Reliable Collections, which of course gets replicated out in your cluster for high availability, so you can do it that way too. So either way you want to do it is fine. And you can see here also in this volume we're referencing a secret, so I obviously don't want to put plain text keys in here, and this is that secret that Mark was talking about here. And you can see in this case I've just inlined the secret, I've encrypted it and inlined it, but of course the other option, if you're in Azure, probably the better option is store that secret in Key Vault where it's good and safe, and then load it in at runtime, and you can use it that way. So that's kind of how the volume thing works there. There are a lot of applications that you can do with this. I think there's another talk tomorrow that Anthony Chu's doing, that's going to show you a little bit more on this topic. So make sure you go check that out, and we'll tell you more about that in a little bit. All right, you want to switch me back here real quick? Okay. So that's volumes. How about diagnostics? That's a good
Well, with diagnostics, we've done a huge amount. In fact, in the 6.2 release that we've just pushed out, we did a huge amount of diagnostics for containers, both in terms of getting the logs out of containers, and you'll see that now gets displayed in terms of inside Service Fabric Explorer, in terms of the logs from those containers. And of course, we've continuously provided you with the first-class capability of taking all your diagnostics and pushing them to things like App Insights. So all the container logs that do standard out and standard error, we push out through, we can push them out to local disk. The container, the Service Fabric App Insights, we can push out into App Insights to be able to view them inside the Azure SDK, Azure portal there. And what we'll also see inside Service Fabric Mesh is that the underlying host itself will have agents running inside it all that will capture the container metrics from those and the container events, and you'll be able to push those out into Azure Monitor. So what that means is you'll see container up and container down events. You'll actually see the metrics for the actual containers running. You'll see the memory usage. You'll see the CPU usage. You'll see the disk I/O usage. So from a portal experience, you'll be able to have this view whereby your container images that are running inside Service Fabric Mesh can see app insights for the application level events. You'll see the container diagnostics events inside there. And then you see Azure Monitor for the runtime events that you see from the underlying platform itself. So we're very keen on making sure that you get rich diagnostics around all these things and see the state of what applications are running inside there.
Reliable collections. All right. And what would a Service Fabric talk be without reliable collections? We're doing some really cool stuff here, actually. So we've done a lot of restructuring in reliable collections in order to, again, enable this kind of vision of polyglot services that can run anywhere. And what we've done is we've separated out a lot of the reliable collections code out from the runtime into separate libraries. And then we've provided different language bindings on top of that. So you get APIs to work with these data structures, these transactional data structures, in a bunch of different languages. And so by separating it out, we can actually do a lot of cool things with it. And so, for example, this is another thing that I think if you've written code in Service Fabric before using reliable services, one of the things that you know is that when you write a stateful service, we've done an okay job of kind of abstracting the stateful stuff out, but there's still you're still writing stateful code, basically. You're still kind of part of this runtime life cycle where you're sort of attached to the runtime. As a stateful service with stateful replicas, we need to tell your service, hey, you're going to change from a primary replica now to a secondary replica. Make sure you handle that. And the reliable collections code does a lot of that work for you, but your code is still in the path. Which means that, for example, if you don't honor this cancellation token that you're given, the system gets held up. So by separating reliable collections out into its own library, what we've also been able to do is have reliable collections be the thing that manages that entire stateful service lifecycle for you. So your service code is now completely separated out of that lifecycle. So basically what it means is that you're still writing stateful services. You're still co-locating your data with your compute for in-memory reads, for lightning-fast reads and writes, but the way you write your code now feels stateless. So when you write your code, it just feels like a regular old Node.js app or a regular old ASP.NET Core app. You're not necessarily inheriting from stateful service, and you're allowing the reliable collections to do that work for you as it talks to the runtime on your behalf. The other cool thing we're able to do is give you transactional storage anywhere you run. And what this means is that even if you're not running on the Service Fabric runtime, you still can use reliable collections and get local persisted transactional data structures. So you can run, for example, an application with reliable collections, and you don't even have to have the SDK installed on your local machine. So as you're developing and debugging, you don't even have to install the local SDK. You don't have to run a Service Fabric cluster. You can deploy it anywhere. It just works that way. Of course, then when you do end up going deploying it to Service Fabric, what you get then is replication for high availability and partitioning for scale out, because the platform will manage that part for you. It's the same code, so you don't change your code at all. You just run it somewhere else, and you suddenly get replication for high availability and partitioning for scale out. So I'll show you what this looks like real quick if you want to switch me over one more time. Yeah. OK. So what I have here is I just took that back-end service, just the data service from our voting application that we were looking at, and I just isolated it into its own solution. Now what you'll see here, what you see on the screen here, the code, this is the reliable collections code being used in that ASP.NET Core controller. So this is just a web API controller. And we've done a few things. We've changed the APIs around a little bit so that we've kind of done this work of creating transactions for you and sort of wrapping it inside this transaction context so that when you get transient errors or something like that, we can actually handle that for you. So you don't need this giant try-catch block to handle every possible exception on the face of the earth. We now do a lot of that work for you. So your code is, again, very, very simple in this case. Now here's the thing. This is just a standalone ASP.NET Core app. And if I go and just run and debug this doesn't deploy to Service Fabric. This is just deploying a console app. And it's just running a console application. Here you can see I have console output because it's just an ASP.NET Core app. And I can hit my breakpoint in here, and I'm actually using reliable collections in here with no Service Fabric runtime underneath. And so this is something I can do, for example, if I'm debugging an application or if I just want to write something up real quick, or if maybe I don't even know where I'm going to run it and I don't necessarily want to start putting in any Service Fabric resources or APIs, I can just do that and run it on its own like that. Now, when you do take that same application, let me show you what this looks like now if you actually take the entire application we had before, pull out that in-memory dictionary and put reliable collections in. The code is exactly the same from what I just showed you. It's the exact same application. I don't need to change any code here. All I've done is I've added these resource files to describe how to run it in a Service Fabric environment, wherever that is, whether it's on Service Fabric Mesh or on-prem or in Azure, doesn't matter. It's the exact same code. And you can see even here, this is now a stateful service with reliable collections backing it. And you can see in my program main, it's again just a regular old service. The only thing I've done is I say go ahead and use reliable collections in my ASP.NET Core app. And so this is the libraries. These are just NuGet packages, just libraries that you pull in. And by doing so, you get access to reliable collections. And then when you do run it on a local machine or anywhere else, it'll automatically start being replicated for you by the platform underneath. So let's go ahead and do that, run it, and we'll show you real quick just hitting that breakpoint. And again, as you can see, these are also running in containers as well. So this is reliable collections being replicated inside of a container with a debugger attached to it at the same time. So this is pretty cool stuff. And then when this application loads up, you'll see it's the exact same app, but now it's just replicated and highly available. And there it is. And we should be able to hit our breakpoint here as well and get into the reliable collections code. And there it is. And now I have my transaction. Again, as a programmer, same code, just running in a different environment and with all the additional benefits of the platform underneath it. All right, you want to switch me back here real quick?
That's super cool in order
Not
to...
bad, huh? All right. So the last piece of this puzzle, we've talked about how you're describing services in order to run them in a kind of platform agnostic way or a language agnostic way, and then backed by some state stores, whether that's volumes, so you don't have to use any specific APIs, you can just write files, or you can use the data structure APIs for more structured data storage. The last piece of the puzzle is here then, how do these services talk to each other? Now the goal with this is we want this to be as simple as possible. So the idea is that if I do have a polyglot application made up of services written in all kinds of different languages, they should all still be able to talk to each other using simple domain-based, DNS-based lookups. And the clients that I use, when I spin up an HTTP client, it should just be the regular old vanilla HTTP client or whatever it is that the language provides. I shouldn't need to pull in an extra library to do this. I should be able to take any code, any services running anywhere, put it onto Service Fabric, and all the discovery mechanisms and everything should just kind of work. And so that's the idea, and that's what's kind of driving the tenets behind this. So services should always address each other just by their host names and nothing more. Very, very, very simple. And you should not have to implement any platform-specific discovery APIs, because again, that then ties you into the platform. So if I have to talk to your discovery API and then I go and deploy it over there, it's going to stop working. So we want to make sure that there is none of that going on. From your service code perspective, it shouldn't look like there's even a discovery mechanism underneath at all. On top of that, services should never have to deal with any network level details. So retries, circuit breakers, throttling, if your code is doing this, that's probably a bad thing. As a service author, you don't actually want to have to deal with these with this level of detail. If you're coming from a world where you're used to making a function call, and the function call always returns no matter what, and suddenly your function call can come back with network errors and HTTP errors and socket errors and all kinds of crazy crap like that, that's a bad world to be in. And so we don't really we don't want the service code to have to do that. We don't want the service code to be coupled to the fact that there's a network underneath or the fact that it's architected a certain way. All of that should be abstracted out. And then finally, and this one's super, super important, when service A calls into service B, I shouldn't have to know anything about the way service B is implemented. I don't care if it's stateless. I don't care if it's stateful. I don't care if it's partitioned. I don't care how it's partitioned. I don't care what version it is. It shouldn't matter to me calling you what your implementation details are. Because if service B decides to change its partitioning scheme, why should service A suddenly break? So these services should be completely agnostic to any of these kind of details.
And the number of questions we get on this particular topic each week is unbelievable.
It's hard to do. It's honestly, it's a difficult thing to do today, and it's something that we are trying to fix. And the way we're doing this is we're kind of partnering with the guys working on Envoy to bring Envoy into Service Fabric. So what this means is that when your services get deployed into Service Fabric, they think they're talking to each other. But what's actually happening is requests are being routed through this network of Envoy proxies, and the Envoy proxies are being configured by these resources, these rules that you can basically upload into a control plane that gets delivered out to these proxies. And what we've gone and done is we've actually built the Envoy APIs on top of our own service discovery mechanism, what we call the naming service, so that can feed information about the clusters and about the location of all the services into this network of proxies so that the services themselves don't have to deal with any of those sort of details. So in this case, you get advanced HTTP traffic routing rules, for example. So your ingress routing can set up rules to say, I want site A.com to go to service A and site B.com to go to service B. All kinds of interesting things you can do that normally you'd have to kind of write yourself with your own front-end gateway ingress service. You no longer have to do any of that. Same with partition resolution. So when a service wants to talk to another service, if that one happens to be partitioned, how do you know which partition to talk to? Well, that should be an implementation of the upstream service, not the client, not the caller. The caller shouldn't care. So what happens is the upstream service is going to tell the proxies, here's how I'm partitioned, and here's how I want you to send data to my partitions. And all you do in your configuration and your routing rules is say, this is the piece of information I want you to pull out from the request. I want you to pull out user/ABC, pull out that piece of information. The proxies do the work of hashing that for you to create a partition key, so you don't have to worry about what hashing algorithm should I use. You don't have to worry about how should I partition my data. If you describe it with a Service Fabric resource and you deploy a stateful service that way with reliable collections, there's a default partitioning scheme that is used so that all this kind of works really nicely and you don't have to deal with it. Of course, you can always go back and configure that stuff yourself. That capability is always there. But if you're just an application developer that doesn't really care about that kind of stuff and you just want your services to scale, this will allow you to do that without having to do all that additional work. So this brings us to what we see as kind of the future of Service Fabric and developing applications on Service Fabric, which is basically a set of polyglot services written in any language, described by Service Fabric resources and adding additional resources to that to help enhance that. Enhance those applications with reliable collections for state storage or by writing just to a file, to a volume-backed file that's backed by reliable collections, and then interconnected through an intelligent network. And
all of these happen across all versions of Service Fabric. So you can effectively think about this whether you're running your existing clusters today. Everything we talked about can be available inside there. You have standalone clusters, it'll be available inside there. And of course, best of all, running inside Service Fabric Mesh, the pure serverless environment, where you don't have to worry about any cluster management, you don't have to worry about any hardware configuration. You just simply have to enjoy being a developer, writing code, and building it inside Visual Studio and any other tools that we support, such as VS Code, to build those simple YAML files that get generated into the JSON definition that you saw get deployed inside there. So we're pretty excited about this future direction of things. We're pretty excited about how we're making it your lives a lot easier to take away the ops side of things from how we run things inside Azure. And at the same time, it's all about simplicity and up-leveling the conversation. We hear so much about how is it that you build, how do we build microservices applications at scale, and how do you do it with the best practices and guidelines. Well, we're building that core into the platform, so you just have to think about business logic that you run inside all of that. What do we have next? I think we have...
Want to see some scale?
Oh,
Let's
yeah,
see some
let's have
scale.
one last demo. So let me switch over to 2007. I just thought I'd show you this. Once that application here got deployed inside Hello World, we have this simple portal here right now. You'll see that here. We've got this little mesh icon here, just deployed inside here. You'll see this portal experience, and here's that network defined. So you'll see all those Service Fabric resources that we talked about. You'll see the secrets, you'll see your volume drives, you'll see your application, you'll see your services, all inside the portal here. And as we release Service Fabric Mesh, you'll have an experience inside here to be able to then look at the logs, hook it up to the Azure Monitor, and effectively see all the diagnostics that are coming out of your applications integrated with the Azure Portal experience. Today we just have this minimal integration around all that. But let me show you one last demo. So I have an application here. If you're familiar with some of the classic Service Fabric, we have this bouncing triangle, which has been a Service Fabric application we've had for many years that kind of shows how we kind of do scale out and upgrade. And I've deployed this application with a single instance of a service that has a single bouncing triangle. So I can do this command now where I'm going to do AZ mesh, and I'm going to deploy into this resource group a new template. And this one scales it all out. So let me just show you, let me just do this for you first. I'm going to go in and I'm going to do this deployment. And while that's deploying, we'll just make sure it kicks off. We'll let this run actually in the background just here. In fact, we'll just shrink this down here a moment, and we can watch that there. We'll see that this starts to, if we go and look at the JSON manifest for this, and I'll just give it a moment first, because sometimes it deploys the first one pretty fast, and you'll see that it'll start scaling out more instances of the back end. Now, this particular application consists of a web front end, and it consists of worker back end. And the web front end is just doing all the rendering, and then the worker back end is the one that's doing all the calculations for any of the given positions for where these triangles are. So this new deployment I've just done, which is this scale out Windows JSON file, let's go and look at the JSON manifest for this. So inside here, this is the JSON manifest for the base image I already had. You'll see that it consisted of it was our application. It consisted of a single web front-end service. It consisted of a worker back-end service here, and I had a single instance replica already running for both of those. The actual deployment of the web front end was this particular containerized image here, which was just a web front end, and I deployed this on the port 80 that was listening. And then, of course, the actual back-end worker role that was running, it had this particular container image inside here, this worker container image. You notice that it didn't have a port exposed, it just set up some resource requirements for what it wanted. And it had a single instance running. Well, in the one I just deployed out, the scale-out Windows one, there is no difference between these templates. In fact, the only thing I did was an ARM template upgrade, where I just increased the replica count size. So if I switch back here now, you'll see now that I scaled out my service from a single instance of back-end one to 3 instances of this running. So the simplicity was enormous. All I had to do was change a single value, redeploy an ARM template, and now I've scaled out my service. Imagine if you want to do that and you want 1,000 instances of your application doing, just change it to 1,000 and you're done.
Well, the important thing here too is if I only had 3 VMs, now I'm in the world of I got to go add more VMs if I was doing that normally on-prem or something. Yeah. So I don't have to do that anymore.
Yes. Nice. And don't forget, you're only paying for what you use. Yes? The whole point of Service Fabric Mesh is you've chosen to deploy 4 container images. You're paying for it in terms of the cost. What's the cost of all this? It'll be exactly the same cost as Azure container instances that you have. So that's for the cost of how you see those particular images, containers that are running. And so you're paying no more for the resources that you're running inside the hosted framework, where we're taking all of the pain and all of the difficulty out of you of managing the infrastructure itself, and you're just having to describe your application and deploy it all. So I can quite easily, of course, change any number of instances across all those, deploy a new image. So what's the next thing I can do? Well, effectively, I can now, if I go back here and take this next Azure command inside here, I've now got an upgrade command here. So let me go and kick off this upgrade command. Let me go on, this one's still running here. So this upgrade may or may not work. So let's just see. Let me just, at this point in time, hang on, let's just, I do AZ mesh app list. At this point in time, the full, so you see here now that deployment's finished in here, and you'll see that this one's scaled out. So I'm now going to do AZ mesh deployment, where this time I'm going to do a different deployment, and this is going to be an upgrade deployment. Well, what do you think the difference is between this version of the deployment I've done from my previous one? Well, it's pretty simple, and I'm sure you can guess. The only difference this time is that I'm upgrading one version of my container image, and you'll see that this is exactly the same application again. This is my application here, which is my set of services. This is my visual objects application. I've still got my front-end web application here with a single instance. You'll see inside here, just as before, nothing's changed inside here. It still uses the same image. But the difference now is that on this particular version I'm doing deploying with, if I open up the code packages you see here, is I've upgraded this to a rotate version now of my container image. So I built a new container image. This version of this container image is a rotating version of those triangles. And now I've deployed this inside Service Fabric Mesh. The only difference I've done is that this one line here is just provided me a new containerized image. And now what we'll see over time is it will start to shut down and do a rolling upgrade across my cluster, just like you understand with Service Fabric does today, in terms of you have all the benefits of the health checks, all the guarantees around the consistency around that. And as it rolls out through my upgrade domains, you'll see a new version of my container image be uploaded, and you'll see the upgrade will take place across that. So this is running a set of Windows container images. We'll let's see that run a moment, and we'll see if it upgrades any of those, but we might return to this later at the end of the talk and just see how the upgrade is done.
It's downloading some hefty images, isn't it?
Downloading a few hefty images, yes, on those Windows container images.
Yeah.
But the whole idea here now is that you as a developer, you don't have to think about now in terms of how you issue any of your particular commands. You can just describe everything inside your JSON file, deploy it up inside Azure. Oh, and there we go.
There's one.
There's one of my spinning, rotating triangles now that's been upgraded just by simply pushing out a new JSON manifest definition up into Service Fabric Mesh. So it's a pretty spectacular way for you to be able to deploy and run applications at scale. So let's switch back to, well, I wish I could leave this, we'll come back to this and we'll see this at the end. So that was scale and upgrade. So scale and upgrade now is as simple as how you just redefine characteristics in your application and submit them into Service Fabric Mesh. And of course, we're also going to bring a lot of those benefits down to other versions of Service Fabric. These are just some of the customers today that run in production. As I said at the beginning, we've seen phenomenal growth with Service Fabric over the last year. Anyone from running a few machines to clusters of thousands of cores. 3 particular customers who've come this year to talk about Service Fabric, Accenture, Honeywell, and ASOS, all have theatre talks. I strongly encourage you to try and listen to some of these. The Accenture one is particularly compelling because we've been working with Accenture now for about a year, where they took a large number of their internal applications and they modernized them and migrated them all to Service Fabric clusters. And in the process of that, they significantly reduced their overall total cost of ownership because they did both server consolidation and consistent deployment with inside Windows containers. So I highly recommend that you go and listen to those talks and then find out exactly how they're using Service Fabric. So they're very compelling stories. Please go and check them out. Other sessions that we have here at Build that are having Service Fabric include Corey's talk tomorrow, where he's going to do a lot around the modernization, and also focusing on the modernization side of things is Taylor Brown's talk on modernizing with Windows Server applications, and the one that follows him is with .NET applications, Windows containers, and they will also talk about how they've used Service Fabric extensively to migrate the existing code and run it inside Azure and get all the benefits of containerization inside Service Fabric clusters. The one talk you should not miss is Mark Rozonovich's talk tomorrow. There's one area else of Service Fabric that we're pushing into very strongly, and that is Service Fabric running on the edge. And in Mark's talk, he's going to have an incredible demo of where he's going to use Service Fabric running on edge devices, showing how Service Fabric on those edge devices provides high availability for your edge applications. So now if your individual devices go down, your applications taking the full power of Service Fabric for the clustering technology we have there, and for high availability on the data as well as the compute can run on edge devices. And he'll show some extremely compelling scenarios there. So effectively now you'll have Service Fabric looking at the edge side of things. We have Service Fabric standalone today and all the improvements we've done there. We have our existing cluster, dedicated clusters, and then with Service Fabric Mesh, we have this full spectrum of offerings now that allow you to have the ease of use of development and the flexibility of wherever you want to run Service Fabric. And then finally, there's a great session tomorrow, Theatre Talk, where Anthony Chu, one of our cloud developer advocates, is going to be diving into more Service Fabric Mesh demos. And inside that, he's going to go a lot more into the volume drives, as he thinks. And what else is he doing?
Yeah. He's basically going to show you some of the more developer-focused side of this, so you'll get a little more deep dive of what we showed you today.
So I know what you're saying is like, okay, you've talked a lot about Service Fabric Mesh. How do I get hold of it? Well, we couldn't quite get it to you ready for build just yet. But you can sign up for a preview. We onboard people on a very regular basis. We have about 500 or 600 people that we have onboarded right now. We're onboarding people on batches of these things. But it's coming in the next few weeks. It's closer than you think. We're very excited to get this into your hands. We're very excited to talk to you about the fact that this is close on the roadmap. Believe me, it's closer than you think in terms of its availability. It will be coordinated at the same time with our 6.3 release, which effectively allows you then to have a single integrated developer experience from the SDK side of things, where effectively you can build Visual Studio applications as you do today, and then take advantage of these resource files that we do. So it's coming pretty soon, and we'll be excited to hear your feedback. Meanwhile, please sign up for the preview, and we'll onboard people as we kind of get space and capacity in order to deal with the demand that we've had. And as always, visit us on GitHub and ask us about issues. Talk to the latest news on our Twitter accounts. And please come down to the booth. We've got hundreds of these T-shirts to give away. We have enough for everyone in this room, at least. Believe me, we carried in hundreds of boxes yesterday and nearly killed ourselves. So please come and get a T-shirt, because we're not taking them home. And we had to find the money to get the T-shirt, so you better come and take a T-shirt. And we're just super excited about everything that's happening with Service Fabric, its roadmap, particularly with the fact that we've now want to provide an experience that you developers can build the most cool things that you can think of, and have to deploy those inside Azure, and provide a platform that you think can be able to deal with the scales and demands and all of the exciting things that you build. Thank you.
So we're happy to take questions. There are microphones, I think, on either end, or just come up and talk to us. Your upgrade.
Yeah, and there it is.
Hey, the upgrade finished.
We returned to it. The upgrade happened, and all three of our, this was the upgrade of our bouncing thing around there. So let's take some questions.
Hello?
Yeah, if you can go to the microphones for a bit, that would be great, because we can capture those.
Yeah, let's do a few questions first.
Yeah, please go ahead.
How to choose between serverless server fabric and functions?
Functions. Oh, okay. Well, so the question is how to change between serverless fabric and functions. Well, as you saw with Service Fabric Mesh, you can actually deploy anything inside a container. So you can quite easily take the functions runtime, build a functions runtime inside Visual Studio, deploy that in a container, and run it inside Service Fabric Mesh.
Yeah, but
how do you choose
which one?
How do you choose?
Well, let's just say, we'd love to see a roadmap. We'd love to see a roadmap where, the offerings of those two converge. Yes? So, I mean, I'm saying that right now you could take that functions and run them inside there. But I'd love to think that those, Service Fabric was designed as a long-running system today, and functions was designed as a short-lived system.
Yes.
in this world right now, you can run a functions runtime inside there. You can do long-lived things with Service Fabric, but we'd love to see those worlds combined. Yes.
And it really does depend on the type of application you're writing.
And kind of
functions are very. Sorry, go ahead.
Yeah, I wanted to follow up on that. How to integrate with Event Grid from Service Fabric?
Can you repeat that?
How to subscribe to Event Grid?
Oh, how to subscribe to Event Grid. Okay.
So good question. So one resource type we didn't actually talk about that we'll introduce will be an Event Grid resource type, yes? So you'll see an Event Grid resource type, and that will effectively configure Event Grid for your deployment and pull in all of the events around for that.
Okay.
So you'll see an integration with Event Grid. We love Event Grid. It's a sister team that works for us because they build on Service Fabric. So that resource type you saw, think of Event Grid resource type. When you see that thing come, the whole thing will make sense.
Okay, thank you.
That should have made sense anyway.
How do you recommend cycling stateless services? Or is that not something that does that indicate other issues? You know, we have an issue specifically where we have some things that are being cached in memory for whatever reason, and at various points we need to cycle the services either because the cache is stale or we have new data or whatever. What are your thoughts on that? How does that strike you?
And you're asking how would you do that in the mesh? Environment,
in
or
mesh
just in
or
general?
on-prem, you know, because at least with the version of Service Fabric we're using on-prem, there isn't like a restart service button, and it seems like a logical thing you'd want to do.
Yeah, so there isn't, okay, so in the APIs we have today, there isn't a thing that just lets you restart. Well, so there are actually fault commands that you can use that allow you to restart individual processes. So that's, we call them code packages in that case. So you can actually restart the code package, which will then effectively restart the process. So if you find that it's failing or something on a specific node and you just want to be able to restart it, there is a command that'll let you restart either the replica itself. The problem with restarting the replica itself, it doesn't necessarily take down the process, but you can restart the entire code package, which will take down the process and just restart the process again.
Okay, so there's kind of it sounds like there's kind of like a hack to do this? Is that...
No, it's just a command in the APIs. So
Okay.
there's an API, if you go and look for it, I think in PowerShell it's restart-service fabric code package or service package, something along those lines.
Okay.
But if you search around for that, those commands are already built in. So it's part of our fault injection commands. Yeah. So that's all.
So you don't have any particular, I guess, negative impression of needing to do that. That doesn't.
Well, I mean, if you're having to do that, there's probably something wrong with the service.
We're caching configurations.
Yeah,
we should take this offline because we can give you a long answer.
Yeah.
Honestly, we'll spend a lot of time.
The short of it is the commands are there to do that. Yeah.
Let's just take a few other questions.
Yeah, so in our instance, we're using Cloud Fabric, and in some of our deployments, we've had issues, and one of the things that we've seen online is that you RDP into the Fabric to get to the event log to be able to see where your deployment fails and everything. It looks like Mesh doesn't have that same capability. Is that correct? And then what is the way to work around this in that scenario?
Oh, okay. So the question is yeah, inside Service Fabric Mesh, effectively everything runs inside containers, yes? You will be able to connect up into the container, and you'll be able to see everything inside the container, and you'll be able to effectively have an interactive session inside the container, and you'll be able to see it from inside there, because effectively that is your VM. That's the world that you see. You don't know what it's running on, or you care about that sort of thing. So you'll be able to see that level of detail around your certainly production level debugging, if that's what you're asking for. And what is it I'm trying to figure out things.
And I mean, those events we want to improve on anyways, and that was something that Mark mentioned earlier, was in Azure Monitor, you'll be able to see all these events that the platform does underneath, like start a container, stop a container. Those things should actually go out somewhere where you can see them, so you don't actually have to term serve or RDP into a machine anymore, because that's really not a good way to manage systems anyhow. So you'll be able to get into the container itself, but a lot of those events should just show up in a dashboard instead, so it makes it easier to see.
Yeah.
Okay.
Think of the container as the VM level thing.
Right.
Yeah, let's take this one over here.
We are already using the Kestrel server with HTTPS, but we have to copy the certificate private key in the solution. It doesn't take it when we add the certificate over the PowerShell. So the private key is not taken when we use so HTTPS endpoint is not available on Kestrel when certificate is in the server. Is it fixed in the new release or new version?
So the question is was it about how to get certificates in a way that Kestrel can read them?
HTTPS
Yes.
endpoint doesn't work when we put the certificate, the private key over the PowerShell. We need to copy in the solution the PFX file, and then it works. So it has to be physically there in the hard coded.
I'm not sure
In the
familiar with that.
Kestrel, web listener used to work, but in the
Yeah.
Kestrel it doesn't work anymore.
We should take a look at that. Come down to the booth in a little bit. We should take a look at that specifically because I'm not entirely
If
sure.
you want to do
what that's
detailed
talking about, we
design
can do that,
questions,
yeah.
we'd love to hear you. We've got 3 days of booth things that we'll just dive into anything like this.
Yeah, show us that one. We'll take a look at that one. Yeah.
Yes.
So scale set related question, you showed you the example of how you just scaled up your services.
Yes.
In the current service fabric world, I have an auto scale set where I say depending on how many resources are being used, memory or CPU or whatnot, I can tell service fabric to scale up my nodes. What's the equivalent of that on the mesh side?
Oh, well, so one thing that we built into the current release of Service Fabric, the 6.2 release, there's two things of auto-scaling. There's using VM scale set to auto-scale the infrastructure, but in the release that we just did, 6.2, there's also auto-scaling of the actual application itself. Is that what you're asking about?
Right.
Yes. The rules that we have built in now to auto-scale the actual service inside Service Fabric, look at the current 6.2 release. It's, you can go into your manifest, you can set up what's called, you can set up thresholds for your service, like upper and lower thresholds and scale amounts that you deploy onto your actual service itself. So you can say both on, I think it's on CPU and on memory for the actual, it's CPUs and memory, I think, yeah.
CPU and memory, yeah.
CPU and
Yeah.
memory on the actual service. You can say if the amount of memory that this particular service goes over above this threshold amount, add this amount more resources to it all, or these number of instances at all. So the 6.2 release has amazing scale out capabilities at the service level built into the platform. We just take advantage of all of that now for Service Fabric Mesh. So from a Service Fabric Mesh side of things, we're there scaling up the cluster. You don't ever see that. The auto scale of your application will be done, as you saw here inside Service Fabric Mesh. But the 6.2 release has full auto scale capabilities with upper and lower thresholds and how much you scale in. And we have a whole document and sample written about that.
But that is the difference, though, right? So you were talking about when you need to scale out today, you write a script that tells the VM scale set underneath to go and add more VMs. So obviously in this world you wouldn't do that because you don't scale out VMs. We manage gigantic clusters. So all you have to do is say, I just want the application to scale out. And one of the resource types that we can then introduce is a scale out rule. So the same way you deploy a network resource or a routing rule resource, you can also deploy a scale out rule resource, which will then instruct the system when you see these threshold hits or when you see these rules hit or whatever, scale out this application. But you don't have to do anything with infrastructure in this case because then we manage that. So it should be a little bit simpler. It should just be another resource you deploy that says, hey, if you see CPU go above 60% for my application, for example, add more instances until it goes below that threshold, something like that.
Okay,
So rather than managing the VM, now I'm managing this at the service level, and each service knows how much the percentage is of like the CPU versus memory.
You're just managing your application. You're not managing any VMs underneath. So you're really just telling the system, scale this application according to my rules, but you don't have to think about the VMs because you don't even see those anymore in the mesh service.
All right, thank you.
Yeah.
Right, we're going to take one more question.
My question is more on tooling about data. So are we getting in the future to have like a data explorer to see the reliable collections?
Oh, Data Explorer.
Oh, Data Explorer. Well, we are still in the process of building a Data Explorer for reliable collections, and you will see one coming, yes. We found that we had to build it on a more generic process, more generic way. We built it so it only worked with sort of ASP.NET Core applications. We're trying to make it work with a variety of different applications, which is the thing why it's taking us a bit longer. But yes, a Data Explorer that you want to be able to see the reliable collections, that is on our roadmap, and good question. Again, we sort of see that sort of around the summer time frame around these things.
It comes with API, right?
Say that
It comes with APIs.
Yes, it'll come with APIs. Okay, we're going to call it done at this point, and then we'll thank you.